Concentrating solar power. This is a different type of solar energy tool than you typically see, like a solar panel on a roof. So why is solar energy important? The answer to that is fossil fuels and global warming. Fossil fuels like coal, petroleum, and natural gas release gas into the atmosphere. These are called greenhouse gases, and they trap heat from the sun in our atmosphere, making Earth's average temperature rise. This process is called global warming, and it's very dangerous for the plants and animals here on Earth because they just depend on cooler temperatures to survive. So how can we stop it? We can replace these fossil fuels with renewable energy. With the onset of climate change, it is important to find more sustainable sources of energy. This diagram here from the EU in 2019 shows all the types of renewable energy they use: wind, hydroelectric, solid biofuels, and solar, which is what we will be talking about today. Some background on concentrating solar power, or CSP, is that it uses a field of mirrors to concentrate sunlight to drive traditional steam turbines or engines that create electricity. Thermal energy is great because it can be stored and used to produce energy whenever needed. This photo here is of the Cerro de Minador solar power plant in Chile. It's the fourth tallest solar power tower in the world, standing at 820 feet tall. The tallest is in the UAE and stands at 861 feet. So how does a solar power tower work? The central receiver can range from 500 to 800 feet. It uses very high operating temperatures to be more efficient. Heliostats that surround the power tower are computer-controlled mirrors that track the sun as it moves throughout the day in the sky and focus the solar energy onto the receiver. Because of the wide range of heights of the towers, you can have a wide number of heliostats, 50 to 50,000 in some fields. The focused sunlight heats a transfer fluid to over 1,000 degrees Fahrenheit inside the receiver, right here. The sun comes in, reflects the sunlight onto the receiver, which heats this fluid. This hot fluid produces steam over here. The turbine then extracts thermal energy from the steam and creates a rotary motion. An electrical generator then converts the mechanical energy from the turbine into electric power that we can use to power our industrial processes, cars, houses, and whatnot. A different type of concentrating solar power is a parabolic trough. Parabolic trough systems use curved mirrors as well and focus sunlight onto a receiver tube right in front of them. Within the tube, a transfer fluid absorbs energy from the sunlight, passes through a heat exchanger over here to heat water, which then produces steam, which runs the turbine, and then creates power, just like in the solar power tower system. These troughs are typically 15 to 20 feet tall and 300 to 450 feet long. So let's talk about the economics of CSP, because if it's too expensive to do, no one's going to do it. The National Renewable Energy Lab has a goal to create a cost of 1 kilowatt hour only costing 5 cents. A kilowatt hour is a unit of energy equivalent to the energy expended in 1 hour by 1 kilowatt of power. So it's a unit of energy. So let's put this into some numbers we understand. The US used 3.8 trillion kilowatt hours in 2020. This was when it cost 6 cents per kilowatt hour. So it cost the US $228 billion if they were to use CSP. But it would have only cost them $190 billion at this new price of 5 cents per kilowatt hour. That both seems like really expensive numbers, but to the US, it's actually a pretty big difference. An average US household in 2020 used about 10,000 kilowatt hours of solar if they were using solar energy. And it would have cost them $642 at 6 cents per kilowatt hour, but this would have gone down to $535 at the new price. This is a photo of Phoenix, Arizona, which has ample sunlight, and these houses could be powered by concentrating solar power in the future. So how do we get to this 5 cents per kilowatt hour? How do we make them more efficient? A parabola brings all parallel rays from the sun to a focus on the power tower. So that means the heliostat must be shaped like a parabola. But as the sun moves throughout the day, you're going to move along your parabola. But our mirrors aren't moving along a parabola. So how do we make them maintain this correct shape? Well, Professor Roger Angel here at the University of Arizona has thought of a solution. place a mechanism on the back of the mirror to bend the mirror to that desired parabolic shape using push and pull. So concentrated solar power would give us the future we want to live in. All right, this is a Fresnel lens. It's smooth on one side and ribbed on the other. On this side, it's a combination of a bunch of lenses of different focal lengths. So you can act like a bunch of lenses at once with the collecting power of all of them, so you can focus sunlight to a really small, intense point. Let's see how powerful sunlight can be. This is a prototype of a mirror that would be used in concentrating solar power. So we're going to focus the sunlight over there. There, you can see it on that pillar over there.